Hi, everyone, and welcome back to my virtual classroom. Congratulations on making it to week 2 of the semester. I'm very proud of you, and I hope you're hanging in there. Got a different view today. You can see in my office, I have this beautiful view of campus, so I'm happy to be here today. Today, we're going to be talking in preparation for our next in-person class about intentional talk and problem solving. So these are some of the very foundational things that underlie everything that we're doing in teaching math. So how do we encourage teaching or learning through problem solving, and then how do we use intentional talk to do that? So this will hopefully make more sense after we get through these slides and after you do the readings for this week. So teaching math through problem solving is a way to support not only students' mathematical understandings, but also their identities as mathematicians. So if you allow students to grapple with ideas and really talk through things and make mistakes, that's where we're going to see the most growth in terms of their identity as a mathematician. So keep that in mind as we're going through this. So in your reading, you're going to read about red dots and blue dots. So this is kind of a graphic of what's going on in your brain as new knowledge is emerging. So that red dot right here in the middle is new knowledge, and blue dots are the existing knowledge. So for example, you might have a student who's learning about, let's say, two-digit multiplication, right? That's the red dot. So it's emerging, and maybe it's connected here to repeated addition, and which connects to single digit multiplication, which connects to something else, right? And then all of that is contributing to this new knowledge. Over here, you might have just basic facts. Over here, and these are all, connected in different ways. This is just an example. But as you can see, the more things you can connect together, the stronger those networks are going to be, and the more they're going to understand the kind of ins and outs of why we're doing things in mathematics and, really in every subject. So we're trying to help them connect to things they know to gain new knowledge. So I want to stop here and have you work with a little example. So I want you to pause the video, and for 2 minutes, you're going to write 5 to 10 things, or really as much as you want, that you know about cornhole. So whatever existing knowledge you might have about cornhole, I want you to write that down and maybe organize it in some kind of way that you can make connections across. So in whatever way makes sense to you, there's no right or wrong answer to this. If you don't know what I'm even talking about with cornhole, then maybe that's what you write down is like something you think it might be or something like that. So pause the video for 2 minutes and write those things down. Okay, so hopefully you're back now. And so if you're not familiar with cornhole, it is a game that you may have seen played at a tailgate or in your backyard or on ESPN, as you can see here. But what he's doing is he has a bag that's a small bag that's traditionally filled with corn, and he's throwing it across into one of these contraptions that's like a board that's slightly elevated with a hole in the middle, and you're trying to get the corn-filled bag into the hole. And you get points for landing on the board or going through the hole is the most points. So that's kind of an overview of the game. So if we look at this in terms of red dots and blue dots, right? Cornhole is our emerging new idea. So you can really look at this and think about it for a minute. What am I trying to show you here in terms of what these three distinct people know or understand about cornhole? So someone in the middle, what would you consider that versus someone over here on the right? So down here, I have a question. Who would be just like a spectator, maybe a freshman player and the head coach of a championship league, and why? So we can see that probably all of these connections and like this broad view that's connected to lots of things they understand would be more of a head coach, right? So this is someone who can see and understand a lot of things about this and connect it to a lot of different things. This might be more of a freshman player, and this is a spectator who can see, who understands what's going on and has some connections, but pretty basic, right? But you can see how the more experiences and the more times you have to kind of think through these things, and maybe even as a player, you're going to connect more synapses across your brain. And so this is really important when we're thinking about mathematics, because in the same way, the more experiences and times we give students to play, right, in the mathematical sandbox, the more connections they're going to make. So in our class last week, we did the shoe problem where we had the case of shoes overturned in the ocean. And so that emerging piece there was finding common numerators. And some of you got there in different ways or more quickly or had some different understanding of what this might look like. But that really the foundational idea there was, are you looking at the fractions as a concept, like what they actually mean, or just kind of going through the motions? And so if you're able to kind of think through what does the fraction actually mean, that's showing me that you have more connections around that idea. And if you don't, that's fine. That just means we need more practice in that area. Finding common numerators is kind of a random thing that I throw in there because it's not something you're real familiar with. So that was on purpose, but just to illustrate the point. So again, we might have some people who have just really early emerging knowledge. Some might have connected it to a lot of different things, like maybe you're thinking about ratios and common denominators, and that's not connected, but it contributes to these knowledges which do connect. And then here we have maybe like the teacher, right, who's seen this problem a bunch of times and has a deep understanding of what the point is kind of doing this type of problem. And so what we want is to help find ways to get students from being a novice to being more of an expert, and making those connections. Okay, so how do we do this? What is a problem and how do students problem solve? Is a big question. So when you're thinking about what do I want to provide my students an opportunity to do in terms of problem solving, this is really important to remember. So a problem is a task or activity for which students have no memorized rules. So if you think back to the shoe problem, you have rules and methods for fractions and you have to have some understanding of those, but there was no prescribed way of solving that problem because it was finding common numerators. If I threw up a addition problem with different denominators, you guys have a prescribed method for that, which doesn't mean it's useless. It just means it's not a problem solving problem. And also the answer is not immediately obvious. So that's important as well to think about. Can they just look at it and know the answer? In that case, it might be a good practice problem, but it's not a problem solving problem. They should have multiple opportunities to participate in learning, and it should be able to be extended up or down. Okay, so these are the foundational things that are important in terms of thinking about a problem that will allow students to grapple with some idea. Okay, so it doesn't have to be a real life problem. It can be, even here, I have a problem that normally you'd use an algorithm for, right? A prescribed method. But if they don't know that algorithm yet, then that is a problematic problem. So if you have a student who's just kind of just working on basic facts, let's say, and then you give them this problem, 27 plus 35, they might use counters to solve it. They might use a hundreds chart. They might just know to add the tens and ones. They might use a place value strategy. So they don't have a prescribed way of doing it. It's a problem. Procedures can also be problems. So if you show them maybe the 2-digit by 2-digit algorithm on the board where you line everything up and you start with the ones and regroup and blah, 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 all of that. If you help them think through, okay, now why am I doing this? What am I doing? That can become the problem, which is an interesting way to approach teaching algorithms. So teaching in this way through problem solving tells you much more about the student's mathematical thinking than just a yes or no problem that you're just checking for correctness. So we're more interested in how they're thinking about the problem, not just what they're doing at the end. Okay, and there's also a difference teaching through problem solving, which is kind of what we're talking about. How do we present students with problems that provide these rich opportunities versus teaching about problem solving? Okay, so that's a distinction as well. So teaching about problem solving is more like conceptual, and it kind of makes it more procedural, whereas teaching through problem solving provides those opportunities to grapple, like the shoe task or the counting cookies task. So it's not about reinventing the wheel. This is really about modifying tasks that we already have. So just some ideas here to think about, how do I get started with this and find good problems? You can take existing curriculum materials and modify them. You can begin with a TEKS standard and generate a list of questions they might have about it, and then generate your problems from there. And also listen to your students. There are things that they might kind of be demonstrating that they're not understanding. Like maybe you give an assessment and you notice everyone is having trouble with regrouping. Sometimes the temptation is to kind of like gloss over that, or if someone says something in a discussion that's like a major misconception, I would challenge you to kind of linger on that misconception and say, tell me more about that, and have a discussion about it to normalize talking through those things and making sure everyone understands the concept. So for a TEKS crash course, and we're going to continue talking about this in class, and you can go to Lead Forward. That's a great place for all kinds of curriculum materials. If you go to the resources page, you're going to see kind of a snapshot of the curriculum by grade level. So I would encourage you to go there and just kind of look through it if you're looking for a crash course on the TEKS. But these are good examples of things that you can modify and get kind of an overview of what are the TEKS in my grade level, and then where I'd be able to insert my problem solving tasks. Okay, so no matter where you pull your tasks from, though, I want you to make sure you consider these are the four kind of important things that we talked about. So it's open-ended, meaning that there's multiple ways to solve it. There's no clear, obvious answer, meaning they're not just going to look at it and be able to mentally solve. There's no predetermined strategy or algorithm for it, so that this is not something that they have rote memorized and they're just doing something, mimicking what you're doing basically without understanding why. And it can be extended up or down in case they need an extra challenge or they need scaffolding. All right, so how does this connect to intentional talk? So intentional talk is kind of a framework for teaching through problem solving that includes some really specific strategies and ways of talking in class that can help you as a teacher implement and be successful teaching through problem solving. So here's some intentional talk. We call these talk moves, meaning that these are things that you can say in the course of a discussion that are intentional on your part that encourage problem solving. So this will make more sense as you read the readings if you haven't yet, but a good resource to have here. So I'm not going to read through all of these, and I'm sorry the spacing got kind of funny when I went into presentation mode, but you get the idea. So one important thing is revoicing. I think this is a good one to highlight. You're going to hear this a lot in our class. So if you ask a student, okay, how did you solve the problem? Tell the class how you solved the problem. And maybe they show you, well, I skip counted here, and then I took my 10s and did this, and then I took my 1s and did that. And they explain it, but it's kind of all over the place. You can say, okay, so am I explaining this correctly? You first did this, and then you took your 10s and your 1s and grouped. Did anyone else do something similar? Okay, so that way you're kind of revoicing what the student said and connecting to someone else. You can also ask students if they agree or disagree. This is important to normalize when students make mistakes, to say, you know, to allow other students to disagree. That creates some really good discussion. So I just wanted to throw these here as a resource for you when you're trying to think about what am I going to say during my lesson. These are some really good things to lean on. So this is just another example with a link to this website that provided these sentence frames that relate back to these talk moves. So some ways to say it that are a little bit different than what the book says, and I think this is really great. So can you repeat that? They're pretty easy to implement, and they make a huge impact. Let's see. And these are things that students should use too. Okay. So students can say, I agree because, and they can provide justification. So this can help students to construct their contribution to the discussion. So if they're nervous about, like, I don't really know what to say, this is a good thing to provide them with, like, here are some ways that you can even have it up in the classroom. Does anybody want to add on? And then they have ways to frame that. Okay. So just another good resource. All right, so that's really all I wanted to talk about in this watch and learn before class. But what I need you to do before we meet next is to watch this, which hopefully you have, and complete the readings. Review the lesson plan template. We touched on that briefly in class. Check the syllabus, bring any questions that you might have. Come to class, of course. I'll look forward to seeing you there. If you need help with anything, please feel free to send me an email. Or I gave you my phone number so you can send me a text message and just give me a little while to respond. And know that you're brilliant and you've got this. And student teaching always feels like it can be overwhelming at times, and it can be really joyous at times, and just kind of ride the wave. And you've got this. All right. I hope everyone has a wonderful rest of the week, and I will look forward to seeing you in class. Bye.